Hey, welcome everyone. This is our session of the Boston.NET Architecture Group. This is November 20th, 2024. And we have Jared Barboza, who's going to be speaking to us tonight. He's got a great topic here that he's also going to be sharing this coming weekend. We have the Boston Code Camp 37, which is an in-person conference that happens. We've been doing that in the Boston area now for over 20 years, as well as this particular group has been around for over 20 years. We're actually celebrating 21 years next month, in the next month or January, depending on when we started. We talked about it 21 years ago and had official meeting in December and then January and kicked off from there. So it's been 21 years. It's amazing. But same thing with Code Camp. It's also over 20 years. And this topic in particular tonight, what I learned from migrating 275,000 lines of microservice code. Fantastic. So Jared, I just wanted to turn it over to you and thank you again for presenting to us tonight.
Yeah, my pleasure. Thanks, Robert. I'll just get my screen shared here. And here we go. Hopefully everybody can see that. And yeah, so I know it's a bit of a clickbaity title, but we are going to be going through a lot of lessons that were learned during a very large and still ongoing microservice migration that is being undertaken at my company. So as I was introduced, I'm Jared Barboza. I'm a lead engineer on the platform team at Huddle. Before we get into all of those microservice lines of code and the migration, I'm going to talk a little bit about Huddle just because I feel like most people aren't familiar with us, given the business that we're in. So Huddle at its core, is a sports video company. Think of us as either Netflix or YouTube for coaches, athletes, recruiters, and fans. And our mission is to build the world's most powerful network of sports video and data to empower teams to make every moment count. And we do that by giving every athlete the shot they deserve. So whether it's, a professional athlete who is on the line of scrimmage in an NFL game, or it's a little league batter getting up there and taking their swings, their coach can help correct their posture, their position, maybe where they're playing defense. We want to make sure that every athlete is seen. Every athlete has that ability to improve. We do this by providing a wide array of products and services. So on screen are just a few of our applications that we offer. And a lot of these are download on iOS, Android, client-side applications. And the biggest part of our operation is our web interface. Here's some other stats that we have. We've been around for a long time, since about 2006. And through that time, we have accumulated about 8 million users, 200,000 active teams, 40,000 active basketball teams. And we're really dominant inside of the high school American football market, with about 99% of high school football being played and recorded on our platform. We also work with a number of professional organizations across the world. You can see a few of them listed here. I'm proud to say that a large portion of the NBA is part of Huddle. But going into more of the technical side of things, like I said, Huddle's a video platform, and it's no surprise that being a video platform, we have a lot of video. At last count, it was about 100 petabytes of video that we store and accrue inside of AWS. At our peak time during American football season, so just passing, we'll have about 22,000 servers at any given moment. Most of them will be dedicated to decoding or coding video and serving it. And we are across 5 AWS regions. So we will host and serve those videos from US, Europe, Singapore, Tokyo, and Sydney. But enough about Huddle. We can go into kind of what this talk is about. And for me, this talk started in about this time in 2023, last year. And I started really thinking heavily about mountains, which is kind of a weird sentence, I know. But what I was thinking about was this really old interview question that would get asked, how do you move a mountain? Um, it wasn't a great interview question, to be clear, but it was a question that got asked a lot. And I was thinking about it because oftentimes when you're faced with a challenge like that, something that seems so daunting and so large, you're kind of lost inside of the the scope of it. You don't even get to appreciate kind of the finer details of it, right? Like if you were going to move the mountain, you'd probably move it rock by rock, right? That would be a good start. Um, but I think in terms of like when we look at a problem like that, in getting lost in those details or in lost in that ambiguity, we miss opportunities to find easier routes or find easier pathways so that you don't actually have to move an entire mountain. And that's kind of what this talk is about. It's really more about how we ended up moving our own massive mountains without actually having to lift the entirety of them. So back when Huddle got its start in 2006, we didn't have a monolith. This is actually Huddle's website from 2006. So we didn't have the monolith. And I think that's important to remember is that nobody starts with the goal of building something like a monolith, something that is so laid down or held down by its technical debt that it's hard to work in, that it becomes something that you have to work around rather than work in. In that case, you know, it's very much like a New England Denny's. Nobody goes to a New England Denny's. You always just kind of end up at a New England Denny's, right? And so thinking about that, coming back to where those mountains are, when we're talking about migrating a lot of legacy code, I think we miss those opportunities to pare that work down. So to cover a little bit of ground of like where Huddle came from technologically and where we are today, we have to talk about the monolith. So from 2006 to 2013, Huddle grew, and in that time, its main interaction point, the website, grew as well, and it had to adapt to many markets. Right, when you're a startup company, you're trying to be very agile. You're trying to go after different opportunities really aggressively, and so you'll take shortcuts. You'll make different changes, technological choices that you wouldn't necessarily make if you had the ability to kind of step back and reassess. But you're really just trying to chase customers and go after them. So there was a lot of growth, explosive amount of growth in those years, both Huddle wise, like business wise, but also technical debt wise. And we ended up with the monolith after about 2013. What we started calling the monolith is just a big, gigantic ASP.NET application, and built on ASP.NET 4, 5 at the time. I think when I joined in 2014, it was ASP.NET 4.5, MVC 3. I think then we upgraded to 4. We had some Silverlight for a time. You know, we really tried to hit all of the technical debt milestones when you build a project on the internet. And it's Windows only, which I think is probably one of the largest limiting factors. As the company began to move out and branch out into other technologies, naturally our engineers migrated more towards, OS X, Linux-based development, just to kind of be in that parity with where they're deploying their code. They want to work in that same space. But we had to maintain these Windows virtual machines or actual Windows VMs inside of AWS to do our development in. And another downside with the monolith is that it had a very custom deployment system, build and deployment system, as one does build when they build monolith. So this gave way to a lot of complaints in the development team. It's really hard to get anything done. It's like moving in mud. We really need to go faster. We need to be able to iterate faster and ship features faster. So that is what brought us out and had what we called the foundation team at that time, the platform team, to develop the multiverse. And the multiverse was our microservices 1.0 iteration inside of Huddle. And we built that on top of the same tech stack that we had for the monolith. If it ain't too broke, don't fix it. So we had ASP.NET 4 again, Windows only still. And we just kind of pared down a lot of the cruft that was inside of the monolith and spun up new web applications. We still had some sharp edges. It was very hard to spin up a new service. Teams had to really embed with the platform side of things in order to get their service deployed and get their service spun up. If you had to deal a lot with, I need a queue, I need a Mongo collection, I need I need a cache, I need all of these things. You really had to work with the platform team to kind of tailor make those things for your service. So that's what really pushed us to go ahead and build out a lot of our building blocks, what we call building blocks. So we build out a lot of these libraries, and a lot of them are just wrappers for common AWS things. So you might build out pub sub events and you're using an AWS SQS right? Uh, Build out a cache on top of Elasticache now, and we had a service registry and a RPC layer. So a lot of these things we built and we tailor made them for what we needed them to do, and then built out public APIs for our development teams to consume and build their applications with. So this was the start of our internal development platform, if you will. So that continued on until about 2019, and or rather, say, sorry, 2015. 2015, we were hearing a lot of rumors or a lot of rumblings about Microsoft going in a new direction. And Microsoft was really starting to embrace open source, and they were starting to really understand that, the future isn't really Windows only. The future is cross-platform, multi-architecture. You can't sit in one platform for too long without becoming dormant. So they were moving towards .NET Core, and they were embracing containers. And a lot of other systems and services were embracing containers. So we decided, why not? We'll do the same thing. So we took our microservices and revved them and did a 2.0. So we tried to learn as many lessons as we could from the past iterations with the monolith, with multiverse, and we coined our new service system called Marvel. And we really wanted to focus on making it easy to create new microservices. In fact, today it's a one-line shell script that you run, make a new microservice, and boom, all of your CI/CD is taken care of, all of your GitHub repositories are created, and all the fun stuff, right? The infrastructure as code, Terraform modules are added. So when we went live with Marvel in 2019, we ended up with about 49 multiverse services, and we had about 10 Marvel services. So we had a really heavily leveraged system that was over into the legacy side of things. And those 10 services that we spun up on the newer framework, Marvel, were done by hand. They were done by the actual platform team. So they were, again, part of a very bespoke artisanal migration process that had not been vetted by the rest of the product team at this point. And I think that's a very key point here, because we'll get into the next slide. You'll see exactly why. So the number of services we have today is much less multiverse services, much less legacy services, 26 legacy services. We have 116 of our new Marvel services in production today. And these next 2 points kind of hammer that migration process home. Like, it takes one squad, which is around 4 to 5 engineers, 4.5 months on average, to perform a migration from the legacy system into the newer microservice platform. And that has been a very hard pill for us to swallow as the platform team, because the longer these older systems stay around, the more we have to support them. And the more we end up kind of leveraging ourselves over into an area where we have to have custom solutions for every new thing we build. We have to go back and say, well, now let's bridge that over into the legacy. And so it becomes very expensive for us to build new things. So back to that mountain. I think we're looking at this and we're wondering, as kind of to ourselves, like, whoa, why is it, so hard to migrate these services? Why aren't product teams just going off and doing this? Why, what's wrong with them? Why can't they just go and migrate all of their code? I think if we peel it back a bit and we kind of structure this mountain and build it up with all of the things that they have to contend with inside of those legacy projects, I think we'll be able to see why they aren't migrating them as fast or migrating them as often as we might want. I think some of the key points here, there's a lot of pain points here, but I think some of the key points that might resonate with other folks who have similar projects is that, this migration is all or nothing. You don't have a middle state. You don't have a half done. You have very spotty test coverage. Tests are usually going to rely on are going to be like end-to-end tests or integration tests, which rely on the rest of the system running, which can be a kind of a deal breaker, really, if you're trying to just run it quickly and understand what you broke. Also, it doesn't really test that, your contracts and data models are correct. It just returns, true that a button is visible and you can click it and maybe you got the same results, but it doesn't really tell you what's happening underneath the hood there. And I think we take that mountain and we kind of zoom out a bit more and say like we have to do this 26 times. I think that really hammers it home. Like there's a lot of work that we're asking product teams to do, and there's a fair bit of this that we're really kind of specialized as the platform team at Huddle. We're uniquely positioned to take on, or at least have a unique perspective on how to handle some of these problems. So that's what spawned this project that we called Jenga inside Huddle. And Jenga is our migration process the platform team undertakes to move a service, a legacy service, over to the new microservice platform. And it's worth noting that as part of this whole planning process for this, we anticipated that we do not know the domain. So we don't understand necessarily, or we can't count on it, that we understand why a service is doing something particular, right? It could be storing data a certain way. It could be relying on data models that have certain relationships. We're not going to understand what those are. So we need to be able to migrate this service from as outsiders, knowing as little as possible about the inner workings of the business logic of the service. But that's why I think we're uniquely positioned to be able to handle this, because we can start moving the things that we care about. And that's what we'll get into here in a second. But the numbers today, we've migrated 13. We have 13 remaining. We take about just a little bit over 2 weeks on average. And that's only with one person as the primary. We may have like one or two other folks cycle in and out as needed to do testing, to do various bits of troubleshooting. There might be areas where a person has seen a particular set of failures or error codes before, so they're more experienced in troubleshooting that. But all in all, it's one person as a primary, taking about 2 weeks on average to migrate these services. And I think if we're going to start talking about where Jenga originated, we have to talk about boulders, because platform team at Huddle, we talk a lot about boulders. And that doesn't mean we stand around talking about rocks all day. We talk about boulders in the sense that if you imagine a rollout of a product or a rollout of a service within platform as a journey that you're taking yourself and the user on from point A to point B, your goal is to remove any of the blockers along that path. So you want to get ahead of the user and say, we're going to remove these boulders or break these boulders down. And you need to understand or pre-plan a little bit so that you know which boulders you need to invoke certain strategies against. So back in 2023 in November, a lot of discussion was had around how do we get away from all of this technical debt? And we realized in discussions that we didn't really have a migration plan. A lot of our planning kind of relied on this fictitious, miraculous step that would happen in the middle. And then eventually we would wind up, ta-da, like all of our services can now go to .NET 6 or 7 or 8 or whatever, what have you. But we didn't really have a lot of discovery or a lot of understanding about what that middle piece was. So it became very clear that we needed to unpack that, and we needed to understand exactly what was going to happen, get ahead of our users a bit, and even ourselves, and understand what boulders were going to be in our way and how we needed to handle those. And I think one of the first things that kind of really crystallized for us was that, thinking things through is great, but theory will only get you so far. You have to actually do the thing. And there's a lot of cruft that gets in your way when you start actually doing it that you just kind of skip over when you're, envisioning the process in a meeting room with some other folks. I have it up on the side, like I need to fix the project file format, but it's very much stuff like that, like the nitty gritty stuff that you can run into and say, oh, wow, yeah, that's going to be painful and a nightmare if I have to do that 26 times. And then the important thing that we wanted to focus on, though, is we didn't want to solve all the world's problems. We didn't want to solve them perfectly. We just needed to be confident enough that we understood enough about the risk and the problem to move to the next one. So you're not trying to fix everything. You're not trying to get everything picture perfect. You're just trying to say, I'm confident that I understand the risk around this particular part of the problem, so I can move on to the next part and start vetting that and getting out further ahead. And this is where we do a lot of analysis on platform team at Huddle. So a lot of our code projects or a lot of our coding is mostly going to be around building out code analysis, especially on this project where we did a lot of code analysis on legacy services. We wanted to be able to figure out, what patterns and components, building blocks are these services using, and then we wanted to understand what the outliers were. So, is there a service that might be using a very old Mongo driver that we need to have a special solution for, or oh wow, this service is using ASPX pages instead of CSHTML razor views, and we need to understand when that is happening or how frequent that happens so that we can understand how to prioritize that work. And this is where we built out a lot of our code. And for us, um, we deal in C# all day long. But if you want to build out a console app, I think Node.js is incredibly easy to do that in. So that's where we did a lot of our analysis work in. Is very basic Node.js code. It's a CLI app we wrote. It clones all of our Git repos and then just walks all the C# files, literally opening them up line by line and looking for, as you see here, interfaces, looking for particular files and paths, looking for method calls, looking for using statements so that we can mark off all of these data points and better understand from a wide view, like what our services actually look like and what technical debt and what options they're using. And we collected, I think, around 20, at least 25 data points that we were using in this. And we would just upload them into a Google Sheet and, track them and basically stack rank them. And then we used a very simple mathematical formula, which is all it is weighted values against each of these columns. And we produced an effort rank. And then we would use that effort rank in all of our planning discussions. So we would know, well, we're going to take on this service in this order because it's a lower effort rank and then this other service. Or we could look at all of the data points in all the columns and say, this is the first service we're going to encounter that uses Elasticache in the old, building blocks. So we're going to need to have a solution for that. So we can bring that in this sprint and start testing that and start looking at that. And that way we're not bogged down when we have 17 more of these to do later on. Basically, we use this as our t-shirt sizes. So I think if you're using a more Scrum process, I guess, you would probably use t-shirt sizes, but we really liked being able to just put a number on this. And since it's just relative comparison between the difficulties, it's really not that big a deal. But it was just easier for us to come up with that. So that brings us to the initial goals of our project Jenga. So the idea was we want to keep most of the legacy code intact, with the thought process being that if we're not changing the actual business logic, that's less of the test cases that we have to actually worry about. Not that we won't run the test cases, we absolutely will. But if we can understand what we're changing, then we'll know the impacts of what we're changing into the system. So to put it a different way, since we know we're not changing the business logic, if a test fails, we know it's something in the platform side of things that broke. And we can start troubleshooting that rather than looking through all of the business logic and the relations of entities and objects and things like that, and trying to understand them. So that was kind of where the Jenga name came from. We're pulling out different blocks and we're allowing those pieces to be filled in by the Marvel side of things, the newer microservice architecture. We wanted to favor fast rollbacks over bulletproof solutions. The idea there is that in talking to our leadership, we said that we agreed that some downtime would be acceptable because we wanted to be bullish on this. We wanted to make sure that we were getting things done, but we also wanted to be obviously respectful of our service owners, of our product team members, and our customers' time. We don't want to have the site down, but we wanted to be confident enough rather than being 100% confident and having that delay a lot of the rollouts. The other thing is we wanted to automate aggressively and we wanted to lean in and save as much of the tedium as possible. So if something is being done 3 times, after the second time, we're automating it. And we're spending that time to make sure that we never have to do it again. And then the last point was, again, going back to the effort rank, ordering the migrations by learning and by effort so that we could figure out when we were bringing in something that was potentially going to extend a migration timeline or something where we might not be able to deliver at that 2 to 3 week interval. So that's our game plan. We have it set. What were some of the biggest challenges that we ran into in terms of once we started getting into the actual migrations, the things that we didn't really plan for, and the things that we had to kind of think on the fly and adapt to. One of the first things was project setup, and this kind of sounds obvious in retrospect, but there's a lot of craft around how you set up a project, and especially when you're migrating and you're thinking about, well, this project doesn't have Terraform, I'm going to have to add that. Or, okay, well, this project doesn't have any of these configurations, and I'll have to migrate them all over. Or this doesn't take advantage of the latest, .NET C# project setup, so I don't have a directory build props, et cetera, et cetera, et cetera. All of that, it really stacks on, and they can become really daunting, and honestly, they can kill your migration before they even start. When you start showing people a huge document that says, well, just do all of these 900 steps, and then eventually you'll be able to actually start the migration process where you have to start changing the code. You're not even at the point where you can start opening Visual Studio yet. So what we wanted to do was really lean in here and go with that aggressive automation. And this is where we decided to focus in on it. And this is where it paid off, I think, the most in terms of our saving our time in the migrations. We created a Jenga CLI again in a Node.js application. Easy to install. It's just an npm install since we have an internal package manager. And we've been able to automate 100% of the initial project setup and configuration. So this tool is going through and it's migrating all of those old C# projects into the newer SDK format. It's deduping and determining the lowest common denominator of packages so it can take advantage of the centralized package management feature from NuGet. It's doing all of our CI/CD setup. It's adding Terraform, every single thing that we need it to do in order to go from zero to start running a .NET build. That's what this tool is doing. And so this is a GIF of me running this earlier this week on a project we have never migrated up until when I ran it. And you can see that the Jenga migrate command is run about 40 seconds. It's taking this project from nothing, from being a ASP.NET MVC 472 project to running on Net 8 and being able to run a .NET build. So I think this is one of the greatest investments of our time. The next thing that we ran into was runtime differences. And again, this sounds obvious, but there's a lot of differences in terms of ASP.NET to AspNetCore that don't have matches in terms of like namespace or class matches. So we had to kind of come up with a mapping system. And we had a lot of issues with internal library differences. So in the older system in Multiverse, your Mongo adapter, your Rabbit adapter, the way you loaded config, they're all different now in Marvel. And how do we handle that? Do we want to change all of that code or how are we going to do that? Because there's code inside of each of these projects that's calling those libraries. And then we have, nicely enough, in AspNetCore, we have dependency injection. But unfortunately, in ASP.NET, we do not, or at least it's not as common as you might hope. And there's a lot of static singletons. There's a lot of static access to objects that we have to deal with. So in this case, abstraction was one of our biggest assets here. We ended up creating a multiverse adapters library. And basically this library acts as the interop layer between multiverse and Marvel. So multiverse code inside of the legacy services still thinks that it's calling the old multiverse Mongo adapter, the old multiverse configuration system, etc. But underneath the hood, the multiverse adapters is just really ferreting those calls over to Marvel and making the backend APIs act nice. But up front, it's dealing with ASP.NET and multiverse calls. So in that case, it very much is like almost mullet adapters. You know what I mean? It's business up front and party out back. I think the one that snuck up on us the most in terms of challenges was async await. And it's really been troublesome to track down because refactors are contagious, right? So you're going to make it a change at one layer and make a method async. All of a sudden, every call to that method in that entire stack now has to be async friendly. And a lot of our legacy services were not async friendly. So there was a lot of dot result, a lot of dot get await or get results, like sync over async issues, which we didn't notice inside of those legacy applications because they're running on very large machines. They're running on very large VMs, sometimes with 4, maybe 8 cores, and they can just sit there and have threading problems and thread contention, and we'll never know. But when we start paring them down and getting them into a container where you have 1/8 of a CPU, and even then it's 1/8 of a dedicated CPU, not a virtualized CPU, because we run on ARM in AWS. That can become a lot of problems for your development team, and it can become problems in production, which is what we saw. So here's where we decided to lean in on our tooling and really build out better thread visualization tools. So we started to update our OpenTelemetry observability. We started to update our structured logging so that we could capture threads in use, worker threads versus IO threads in use. And what you're seeing here is 2 graphs that we've been able to surface to the product team. And they become very standard troubleshooting operations now as part of our migration efforts. We're able to see in 2 different production incidents here. In the top one, we're seeing thread contention. So we're seeing a high number of threads being spun up and then dying off shortly after. But during those spikes, that's when you would see low availability. That's when you'd see the service say, I'm unavailable, right? Or I can't take any more requests. Or you might actually see Mongo timeouts because Mongo couldn't give the data back to the service because it's too busy doing and waiting for other things. And in the bottom graph, you're actually seeing thread starvation, which is threads are coming on, staying on, and they're basically getting locked. 2 or more threads are getting locked, waiting for each other to stop, basically. They're both contending over the same resource. And being able to surface these to the product team was invaluable. And we've been able to actually catch a lot of these problems now inside of our test environment, but also provide tooling that helps level up a lot of our product team members and be able to troubleshoot production incidents more efficiently. So yeah, investing in our tooling was a big help there. Getting the core libraries updated was another step that we took here to make sure that we weren't surfacing any more of those non-async methods so that we could catch these errors as compile time problems when we start doing migrations. And adding Roslyn analyzers to all of our migration steps, again, leaning on that automation to make sure that they're included in those new migrations, will really help us be able to capture these way before we actually get them out to production. And this one is very interesting because it wasn't another one that we didn't really think about ahead of time or didn't anticipate. Was we have a legacy front end CI/CD system that's built on Node 5.12 and npm 3.10.9, and yes, those very specific versions for very boring reasons. But the second bullet point here is actually the biggest kicker, is that it requires a case insensitive file system in order to work, because a lot of the JS libraries that we use they will require a path, and the file path that they are trying to load does not match the case of that file or the folder that it's in on the disk. So this can become a real hazard when you start doing builds locally on your Mac, which is case insensitive, or on your Windows machine, which is case insensitive. And then you go and ship your code off to our build system, which runs on Linux, which is case sensitive, and your builds fail. And it can become quite a pain. So we ended up having to do a different strategy here, which was called avoidance. And it's the best kind of strategy where you just go around the boulder. You don't actually try and break it down. You don't try and go around it. You just try and do as much as you can to avoid the problem and deal with it either later or wait until it can no longer be a factor. And that's kind of what we've chosen with our legacy builds here. They still run today. We've just moved them off to Windows-only machines. We still keep a small subset of those around just so we can run these front-end builds, and then we heavily cache them, the outputs of those. So we're trying to reduce that build time as much as possible for our developers. And I think the last one here is this legacy Mongo driver, which is really a scary one for us because a lot of these queries haven't been touched in a very long time. I think eight or 9 years, in some of these cases. So again, going back to the whole, we're not the domain experts. I don't think you can get any more into the realm of being a domain expert than at the data layer, like when you're trying to make a connection to the database and do some joins or do some queries. So the library that we were using, we needed to upgrade it because it's blocking an internal migration effort from another platform team where we want to move away from our internally hosted Mongo servers. We want to move away from that over to AWS Serverless Document DB, and we need a specific library version of the Mongo C# driver to do that. And these projects aren't using that driver, and they're using a very old query format. So again, these aren't, things that there's no experts for these really. These people have moved on to either other teams in Huddle or other companies. So what do we do here? This was actually a surprise to us all, I think, but AI ended up being a really good solution here. One of the few times I think I'll ever say that is that AI actually turned out to be a very good solution. We could actually just ask it, hey, I have this query in Mongo driver 1x. Can you convert that over to 2x and make it async? And 98% of the time, it was successful in doing it. We still went through and verified every single query, every single line. But after a while, when you start seeing, examples of positive migration, you start saying like, oh, over here on the left-hand side was what it was. This is what it is. I can reasonably understand how you got to those, from one to the other. Now I'm starting to click. We were able to even become familiar enough with the migrations ourselves to start doing a lot of these and then just gut checking our migrations against the AI and just ensuring that, okay, we're both getting the same answer at least. And when I say 98% successful, there were a few cases where the code generated just didn't work exactly as we expected. It missed an assignment or it missed a key feature that one query had that the new query was missing. So again, AI is not a silver bullet, but it's very useful in saving a lot of the time in these migrations, especially when you're doing old code API to new code API. I feel like it could be a very big tool to use there. So moving into lessons learned, like what are some of the things that coming out of this process that we've been through the last, I think, six or 7 months? What are some of the biggest things that we've learned about the process about migrations? So for us, like I said, in platform, we talk about dealing with boulders a lot. We talk about dealing with roadblocks, things that are going to stop us in our tracks, things that are going to stop our users in their tracks. And doing this project has taught us a lot about our tooling with that, giving us a lot of other things in our tool belt to kind of pull out and say, wow, we can probably try this solution here because it's worked in the past, and having a lot of those, documented use cases for the rest of platform team to lean on. And it's given us a lot of that muscle memory to break down problems into their simplest form, right? When you're trying to look at, well, all I'm trying to do is get this particular thing to do this. And for us, it's a lot of that is I'm just trying to get this service to think that it has, an outdated or very old Rabbit MQ library. I can probably abstract that away, right? And get the newer library to just be called by that. And as one of our engineering managers loves to talk about, he says, what if our problem wasn't our problem? And this is where we favor buy over build at Huddle, leaning on open source. We're not particularly beholden to a piece of technology. Anything can be replaced as long as we can find technical reasons to do so. I think that really helps us be nimble and really move quickly to solve some of these problems. Another thing we learned is that there's not opposites between reactive versus proactive. Both are very valid approaches as long as you are direct and intentional with why you're choosing them. I think a good case study for this in our migrations was when we had those production incidents with threading. We were what I would call reactively proactive. So we would wait until we could prove or it was proven that it was a factor of the migration, and then we would jump in and own the issue. So not to say that we sat around and let production, have issues, but we really relied on our users to leverage tools. And if the tools were missing, we would provide those tools or we would help them figure out that information, just so that we could not be on every single call that was happening if something was going on inside of a service that we had just migrated, so we could have that buffer time and say, okay, this is a problem. We need to understand the impact of it. And once we knew that it was a particular issue was affecting a service, we could jump in and start solving that problem for that service owner and then retroactively for every other service that was affected. The other thing that we've leveled up here in our migration process is communications. Internally, we use Slack. We spend most of our time communicating through that. So we created a dedicated Jenga channel for folks to come in and ask questions. We had office hours twice a week inside of there for folks to ask, will this, how does this affect my service? When will my service be in, the migration rotation? But also building out a communications plan is incredibly valuable in long-term or large migrations like this. Draft your Slack posts, draft your emails, create templates, post them wherever you need to so that every team member has access to them, so that you can ensure that every single migration milestone gets the same exact message posted. And it's incredibly useful because it gives you not only does it make sure that no matter who's doing it, you can be sure that they're sharing the right information, but it also lets you have a place to go back and update those. So if you find something new or you want to add something to the notifications or the milestone message, you have a place where you can go and do that, and it will just get folded off into the next post that happens. The last bullet here is definitely not the least important. It's one of the biggest things is make sure you're celebrating your milestones when you're doing long migrations, even if they don't seem like they're it's the 26th time that you've done this particular thing. It's still worth celebrating because every time you're taking away a piece of technical debt, that's a thing you no longer have to maintain. That is a box on a shelf that you no longer have to pay to store. And I think also it's worth mentioning that, like you said, we weren't trying to be perfect. We're trying to be confident enough. We wanted to be sure enough that we could go to production. And it can be beneficial to do that, especially if you have an excellent ops culture, a great RCA and postmortem process, the ability to roll back fast. Those can be incredibly useful and let you go to production sooner than you might otherwise be comfortable with because you have that parachute. Now, you want to watch out and make sure you're not doing this again and again and again and again, right? Because you want to make sure that maybe, you go a couple of times, two or three, in worst case scenario. And by the third time, everything's bulletproof. But being able to deploy to production and see that it's working and see what's not working and then roll it back is incredibly invaluable. So if your tooling is not quite there yet, I would really invest in that because investing in your tooling always pays off. And then I guess the last part is the thing that we've realized, or at least I've realized as part of our team, is that there really isn't anything that's impossible. We just haven't figured out what we know about it yet. And that's my spiel. Yeah. I'm happy to take any questions that folks have, and you can get in touch with me at the URL below my name there.
Okay, any questions? Thank you, Jared. This was fantastic. Really appreciate this. I like the details and the approaches, especially that one about avoidance. That was a great strategy as a warning. Okay, yeah. So anybody online, anybody have any questions?
So I kind of have one. It's Rick Levin. So it sounded like you weren't actually rewriting the software to take advantage of the changes in .NET Core. It was more of just a lift and shift. How do we get it over out of the old platform with as little change as possible?
For the most part, yeah. So there are parts of it where I'd say that's very fair to say around the controller code. So if you're looking at a service where they have a lot of controllers or a lot of background services, like we are not touching those. We're not really changing that code so that it gets any of the newer improvements other than what might be innately improved by the runtime,
Right.
But I think that there are a lot of improvements that we've made to our internal runtime, to our internal platform that folks are getting and they're excited about. Um, I think, for example, before you used to have to do a very long deployment and rollback process if you changed a config and it was wrong. Today, you're just changing that and publishing the config separately. There are improvements like that that folks get to take advantage of because their controller actions have not been changed. However, what their code is now running on is the newer platform. If that makes sense.
Kinda, but it sounds like they still have plenty of plenty of room for improvement if you want to then go back. So as a tech debt and start refactoring the older code that you've still fundamentally carried over and said, how can we actually throw in async await and, better link and better entity framework and web API and, all some of the goodness that wasn't there so long ago.
Yeah, there's a lot of that. So there's a fair amount of that we are doing around, I think just a couple of bullet points like the async awaits,
Mm.
and some of the web API changes that we've done. I think those improvements just kind of come along for the ride in terms of our migration steps. But yeah, for squads that are receiving these services, the feedback that we've gotten is they're incredibly excited because now they get to actually go in and not necessarily like start refactoring huge swaths of their application, but when they're working in that system, it's so much more familiar to them and they can look at all of the experience that they've had the past 5 years working in our newer IDP, and they can actually leverage that experience now in the older system and know it's going to work exactly the same.
Mm. Nice.
Great. Any other questions? Okay. Well, Jared, again, thank you very much for presenting tonight. This was fantastic. I'm sure some folks will look forward to this as well this Saturday at Boston Code Camp when you present, and certainly wish you the best in that presentation that you delivered. But this was stellar, fantastic. Really appreciate it. And thank you again.
Thank you for having me. This is a pleasure.